What's up? What's up? It's your man Jimmy Chan. All right, so let's get LabWork 11 out of the way. All right, so what we have here is log base 2 of 4x. So it's 4 times x. So we have a rule for that. So since it's multiplication, it'll be the same thing as addition. Ooh, excuse me. So I have log base 2 of 4 plus the log base 2 of x. All right. Now, I can write the 4 as a base of 2. So I can do log base 2 of 2 squared plus log base 2 of x. Okay. All right. With that being said, the log base 2 of 2, well, first of all, let me do the power rule. So I'm going to have 2 log base 2 of 2 plus log base 2 of x. Then what I do know is this, that the log base 2 of 2 right there is actually equal to 1. So it would be a 2 times 1 plus log base 2 of x. So really what I have now is 2 plus log base 2 of x. So that is choice B. There we go. All right, so that's my answer right there. All right, that's 1. Number 2. I have division here. That means I gotta subtract. So this right here would give me log base 3 of 27 minus log base 3 of x. Awesome. So I can write the 27 as a base of 3. So I got log base 3 of 3 to the third minus log base 3 of x. The power rule gives me 3 log base 3 of 3 minus log base 3 of x. So again, log base 3 of 3 is going to equal to, you're right, 1 minus log base 3 of x. So with that being said, this is going to equal to 3 minus log base 3 of x, and that is going to be choice B. There we go. That's number 2. All right, on to number 3. Ooh, what is this? Well, I can write a cube root of y as a power. So I could actually write this as log base 4, right, of y raised to the 1/3 power. So let me do this really quick, bring it down a little bit. All right. So because of that, since it's to the 1/3 power, right, because the power is on top, the root is on the bottom. Okay. And the power to the y is y to the first power, and the root is a 3. That's why it's to the 1/3. Now, based on the power rule, what do I have? What do I have? There we go. I have 1/3 log base 4 of y. And that is choice D. There we go. Excellent. All right, on to number 4. What do I have for number 4? Oh, look at this. Look at this. I got division, some power. So let's see what I get here. So what I have is log base 6 of x minus 4. Since it's dividing, it's subtracting log base 6 of x to the 4th. And since I have to the 4th power, this is going to be a log base 6 of x minus 4 minus 4 log base 6 of x. And that's about all I can do. There's nothing else I can do with this, so therefore this is choice C. Boom, there we go. Whoop. Whoop. All right, so on to number 5. Base B, I'm subtracting, so I must be trying to compress here. So what I'm gonna do is, number 1, I'm gonna go ahead and deal with this as a power. So what I'm gonna have here is a log base B of q to the 6th power minus log base B of r. And since I'm subtracting, I'm going to be dividing. So that means I'm going to have a log base B of q to the 6th over r. So there we go, and that is choice D. Nice. All right, there we go. And on to number 6. Uh-oh. So the question is, can I get the same base on both sides? The left has a base of 4. So I have 4 raised to the 7 minus 3x. Is equal to. Now, can I write 1/16 as a base of 4? Well, I can write 16 as a base of 4, right? So this is 4 squared. But I need it up top, not on the bottom. So if I was to write it up top, what would that be? Wouldn't that just be, actually, you know what? Let's do these. Go. So with that being said, I can write this. So I got 4 raised to the 7 minus 3x is equal to, if I want that 4 squared from the denominator up to the numerator, I can write this as 4 to the negative 2 power. That would bring me up top. Now I do have the same base, right? Because I have the same base, I can say that the powers must be the same. So that means 7 minus 3x must equal to negative 2. All right, so then I solve from there. I'm going to add the 3x over to the other side and add the 2 over. So x is going to equal to 3. Okay, and that is going to be choice B. And there we go. On to number 7. Ooh, is it E? How do I get rid of E? What's the opposite operation of E? That would be the ln. So let me go ahead and duplicate this actually. Let me just bring it down. And not just bring it down, but I need some extra spaces here. Okay, so to get rid of the E on the left side, I have to take the ln of it. But if I take the ln on the left side, I gotta take the ln on the right side. And since the E and ln are opposite operations, my left side is only gonna be a 5x left equal to ln of 8. All right, well, I gotta solve for x. So I'm just gonna divide both sides by 5 so I can get x by itself. Well, that'll be ln of 8 divided by 5. So there we go. And that, ladies and gentlemen, is going to be choice A. There we go. On 8. All right. This is where I can't find a common base, right? I can't make 3 as a base of 4, and I can't make 4 a base of 3. So if I'm stuck, then I can either use the common log or the natural log. And I already told you guys that my preference is always about the natural log, right? So what I'm going to do here, I'm going to take the natural log, the natural log of both sides, right? And what I'm going to do from there is the power rule here. So I'm going to have the x plus 7, which is my power, times the ln of 3 is equal to the ln of 4. Well, I'm still trying to get x by itself, so I'm going to have to distribute this ln of 3. So I'm going to have x ln of 3 plus 7 ln of 3 is equal to ln of 4. Okay? So let me see here. Again, I'm trying to get x by itself. So guess what? The x can be isolated by itself right now, right? So if that's the case, let's do that. Let's go ahead and subtract the 7 ln of 3 over to the other side. So I have x ln of 3 is equal to ln of ln of 4 minus 7 ln of 3. Right? So I'm just subtracting this over to the other side. Right? Okay. So with that being said, now I can get x by itself by dividing both sides by ln of 3. So I got x is going to equal to ln of 4 minus 7 ln of 3 all over ln of 3. And when you look at the choices has decimals. So you're like, okay, so I'm going to need to do, let's see here, parentheses, ln of 4 minus 7 ln of 3. Oh, shoot. Parentheses, ln of 4, close parentheses, minus 7 ln parentheses 3, close parentheses, divided by the ln of 3, close parentheses. All right. That is not what I get. Let's see here. That's what I got here. So I got x is approximately negative 5.73814 blah blah blah. So which is going to be choice C. And there we go. All right. So that's number 8. Number 9. Okie dokie. Number 9. Same idea. Right? Same idea. I don't have the same base, so the best thing to do is to go ahead and take the ln of both sides. The power rule, so I have the x plus 6 times the ln of 5 is equal to ln of 2. So again, I still got to get x by itself. So same idea, I got to distribute that through. So I'm going to have x ln of 5 plus 6 ln of 5 is equal to ln of 2. All right, to get x by itself, I got to subtract that 6 ln of 5. So I got x ln of 5 is equal to ln of 2 minus 6 ln of 5. And then divide the ln of 5, so I have x is equal to ln of 2 minus 6 ln of 5 divided by ln of 5. So that would be my answer there, which you're like, dude, that answer is not there. You're like, well, here's what we could do. We could split the fraction, right? We could say that this is equal to ln of 2, let me do it this way, ln of 2 over ln of 5 minus 6 ln of 5 over the ln of 5. And if you notice what happens, look, ln of 5, let me do a different color here. Oop. 5. Let's see here. There we go. If you notice that ln of 5 and ln of 5 here would cancel each other out, right? So it would be left with a 6. So what I really have here is that x is going to equal to ln of 2 over the ln of 5 minus just a 6. That choice, however, is there, which is choice D. Excellent. Oh, look at that. On to number 10. All right, so I see log base of 35 and log base of 35 on both sides. Why not get them together, right? So let's get them together. So I'm going to have a log base of 35 of x minus 2 plus log base of 35x, and let that equal to that 1. Okay, so basically I am adding this over to the other side, and that's why I got that. Okay? Okay, so with that being said, oh, this is addition. That means, really, if I go in reverse, I'm actually doing, I can put them together as log base 35 of x times x minus 2, and that's equal to 1. All right? Ooh, I have two methods of going here. I can convert this to the exponential form, which tells me that 35, actually, remember what I said? I said leave them and just move the base. So I got x times x minus 2 is equal to 35 to the first power, which is x squared minus 2x is equal to 35. Huh, look at this, guys. I see an x squared and an equal sign. Would that mean I have quadratic equation, which is ax squared plus bx plus c is equal to 0? right? And I got to factor the non-zero side, right? So great. So I got x squared minus 2x minus 35 is equal to 0. So I'm going to have x minus 7, x plus 5 is equal to 0. So I have x equals 7 and x equals negative 5. Question is, can I use either one? Can I use both, or can I only use one or the other? Right? So here is the biggest part. We have logs here, and it's log base 35, but I want you guys to know, oops. Oh, shoot. I want you guys to understand something. Number one, I cannot take a log of a negative number, right? So if I was to graph the log of x, it would look something like this. Very close. Close, very close. Okay, so we'll just leave it that way. So this is kind of if y is equal to log of x, okay? So this is more of a common log, but all the logs are pretty much the same way. And we notice that the domain here doesn't allow me to use any negative x values. So that means I would have to reject this, because no matter if I put it up here, in here, if I put a negative 5 in here, I'm going to have a log of negative 7. I can't take the log of negative 7 because negative 7 is somewhere over here, right? And it doesn't exist, okay? And it doesn't matter if I put it over here. That would be log of negative 5, which doesn't work either, okay? So I have to reject that, and my answer, is going to be x equals 7, which is choice C. And there we go. All right. Well, I hope this helps. If you got any questions, let me know. Talk to you later. See ya.